Alright folks, so here we are doing projectile motion, and the first thing we're going to do is, there's three questions here, and we're only going to answer this one in this video, okay? So a cannon is fired at a 30-degree angle from the horizontal. How high will it get? So what that looks like is, this could be anything. For here it's a cannon, and this thing is, kind of, going to do this. It's going to kind of go, and it's going to land here. And this angle right here happens to be 30 degrees, okay? So 30 degrees, pardon my drawing here. But that's 30 degrees from this horizontal. So here's the horizontal, just to let you guys know. Remember, this is vertical, this is horizontal. So 30 degrees from, that means from here to right there, that angle there. So it's going to be 30-degree angle. So know that when this thing does take off at this 30-degree angle, and it's going a certain speed. Oh, and I forgot to add I forgot I should put at, and let's put 20 meters per second. You got to give it a speed here, right? The faster you go, the higher it'll go, the further it goes, stuff like that. I forgot to mention a speed. So there we go. It's moving at 20 meters per second. So it's moving 20 meters per second here. But remember, there's technically like a velocity in the x direction and a velocity in the y direction. There's two. The cool thing is to solve number one, if that's all they're asking is how high will it get, they only want to know one thing, is how high it goes, and that means we only care about this. Okay, so all our work is in the y direction. We don't care. Remember, x is independent. It's moving to the left, to the right, really fast or slow. I don't care. I just care how fast did it head up. That's all we care about, is how fast did it head up, because the faster, as we know from one-dimensional problems that we've been working on all last week, is that the faster this heads up, the higher it goes, and that's that. So we only care about that. So how do we solve that? That's going to be the sine, okay? So we're looking at sine for the y direction, and that's just a quick review if you want to look at that one. So remember, sine of 30 degrees of that angle times 20 meters per second is going to give you our speed, okay? So the sine of 30 in a calculator is 0.5. You can double check that if you like. Times 20 is equal to 10. So this thing is heading up at 10 meters per second. That's not our final answer. We want to know how high it goes. So let's do all our work in the y problem. We know that the initial speed in the y direction is plus 10 meters per second. We know gravity will try to pull it down at negative 9.8 meters per second squared. And we know when it gets to the highest spot right here, that in the y direction, the up and down, this direction right here, up and down, its speed right here, the final speed, is going to be 0. It will then speed up, okay, I know that, and by the time it hits the ground here, it's going to be going negative 10. I don't care about all this. For this problem, I don't care about that. I know it starts at 10 here, it's going to end at 0 here, and that's what I'm trying to find, is this x right here. That's our question. How high will it get? We're trying to find delta x right here. Okay, so we are looking for delta x, and we do know that the final speed is going to equal 0 meters per second when it gets there. And the equation for that is this one right here. It's the only one that will fit, plus 2a delta x. So let's go ahead and solve it. Let's put our final speed squared is equal to our starting speed squared plus 2 times negative 9.8 times 10. Times delta x, and we don't know this. So this right here is going to be, what is that, negative 19.6 times delta x. And then this positive and a negative, it's just going to be negative then. 10 squared is 100, is equal to, what is this going to be? 0 squared, which is 0. Then let's subtract this 100 off, okay, sorry, and subtract the 100 from here. And then we're going to get negative 100 over here on the left side, and we're going to get negative 19.6 delta x. Now all we have to do is take the negative 100 and divide it by the negative 19. I'm going to kind of continue that work here. I wonder if there's a way I could do that. No, there's not. Alright. Sometimes there's a way I can grab this and move it. But I'm just going to continue my work over here. So then I'm going to take the negative 100 and divide it by the negative 19.6. Wait, was there a way to scroll? I think there is. I think. There we go. I can scroll down. That'll save me time. All right, so then let's just divide by negative 19.6, divide by negative 19.6, and then that gets rid of that. And it's going to be about 5-ish, a little bit more than 5. And we'll just remember how to find the calculator. We go here, type in calculator, and we'll just do 100 divided by 19.6. They're both negative, so we're going to get a positive at the end, and it's 5.1. All right. So delta x is a positive 5.1 meters, and it should be positive. It is above where it started, correct? So it will be positive. And that's our answer right there, 5.1 meters, and that's the end of this video. Remember to pause it and rewind it and watch it over and over again and take notes if you have to. You know, what equation we're going to use, what's the knowns and the unknowns right here, right? The knowns and unknowns. What equation are we going to use? And then we just kind of plug that stuff in there and just do a little bit of algebra, and we're done. And we're only solving this one right here for this video right here, this first one. How high will it get? All right. So that's it.